Alright, this is 7.9, negative exponents. We already learned this. Maybe I jumped the gun a little bit, but this was the real man, right? Negative exponents wants to be a real man. You know the story. You love it. Remember it. You'll never forget it. So this is the actual unit on it, so it should be so easy for you. So 7.9. Let's go ahead and start making a chart. We did this before. 2 to the third, which is equal to 2 times 2 times 2, is 8. We start rolling that down. 2 squared is 4. 2 to the first is 2. And we see that we can divide by 2 every time, and we'll get the answers. 2 to the 0, when I divide 2 by 2, is 1. 2 to the negative 1, if we're still dividing by 2, 1 divided by 2 would be a half. 2 to the negative 2 would be a fourth. And so I hope you see the pattern there, okay? Remember what we said? Negative exponents. A to the negative n is a negative exponent. It wants to be a real man, so it jumps down below the line and it turns into a real man. Alright, so let's try this. Rewrite using positive exponents. Okay, so 11 to the negative 2, it wants to be a real man. You got to pretend like this is a line over 1. So it would jump over the line and becomes 1 over 11 squared, which is 1 over 121. If the numbers get real big, I don't mind you leaving it as 11 squared if it's like 11 to the 7th power, okay? If it's just squared, you can change it. Alright, how about this one? 6 divided by 6 to the negative 2. 6 to the negative 2 wants to be a real man right here, so it's going to jump to the top. So we're going to get 6 to the first times 6 to the second. 6 to the first times 6 to the second. We're going to ignore all this right here and jump right here is 6 to the third power. Okay? Now some important things to remember. Remember that when we have exponents, x to the third, x to the ninth, when the bases are the same, we subtract. There's two ways to do it. You can say there's 3 and 9 and there's more down here, so that would be x to the 6. We subtract. Or you can literally subtract them. You could say 3 minus 9. 3 minus 9 is x to the negative 6, and then that jumps to the bottom. So doing it this way and doing it this way are the same result. Alright, now here's a summary of our rules about exponents. And we did this in the first semester, and we'll do it again in the second semester. M and N are integers. A and B can be anything except 0. So when I have the same base, b to the m times b to the n, when we multiply, we add exponents. Say it again. When we're multiplying, we add exponents. For dividing, we subtract exponents. That's number 2. When we have an exponent raised to another exponent, we multiply those exponents. So 7 to the third raised to the x power is 7 to the 3 times x power, or 3x is a good example. Okay, with just variables. A, b to the m power means that everything inside the parentheses is raised to the m power, a numbers and variables. So it can be written as a to the m, b to the m. So if I have 7 times x to the third power, that would be 7 to the third times x to the third. Number 5 works with division. A divided by b to the m power, m, a to the m over b to the m, everything inside the parentheses. And then number 6, we just did. A to the negative m wants to be a real man. It's going to jump to the bottom. And lastly, just kind of remember this. Any number or variable to the 0 power equals 1. So a to the 0, 10 to the 0, a million to the 0, your mama to the 0, always equals 1. And that's it. 7, 9.